Okay, good afternoon to all. We'll start the session now. So, in last lecture, we have finished our first unit. From this lecture, we'll start the second unit. So, beforehand, I would like to show you the content which we are going to cover in this second unit. Is this PDF visible to all of you?
Yes, sir.
Yes, sir.
Okay, so this first unit, that is number system, digital logic, families and logic gates, this we have finished in last lecture. Now the second unit is combinational logic circuit. So it has this content which we have to cover. So the first point in that is standard or canonical forms for Boolean function, then minterms and maxterms. Second point is simplification of logic circuit by way of sum of product or SOP and product of sum or POS. Third point is expressions simplification using Boolean algebra techniques, that is K-map. And fourth point is construction of half adder and half subtractor using K-map. And fifth one is necessity, principle, and types of multiplexer and demultiplexer. So we will see all these points one by one. So the today's point of interest is first point, that is standard or canonical form for Boolean function, minterm and maxterm. So give me a minute. Let me present you the PPT first. Okay. Is this PPT visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Canonical form of Boolean function, canonical or standard, we can say. Is it visible now?
Yes, sir.
Okay, fine. So today's topic for presentation is canonical form of Boolean function. I am ST Kumbhare, lecturer, electronics engineering at Government Polytechnic, Gondia. So the topic for today's presentation are minterm, maxterm, canonical form of Boolean function, which has two parts. One is sum of product, that is also known as SOP, product of sum, that is POS. Now, outcome of today's presentation are we will be able to identify minterm and maxterm, write Boolean function in sum of product and product of sum form, that is canonical form, and then differentiate between minterm and maxterm. So what is minterm? For a switching function, means whatever functions we will see like this, for these switching functions, a literal, okay, literal is defined as a variable in uncomplemented or complemented form. For example, x, then x bar. So this is uncomplemented, this is x bar is a complemented form. Y and y bar, so etc. Like this we can have different. Here also you can see literals a, b bar, c, a, b bar, c bar, a, b, c. Okay, so all these are literals. So for a switching function, a literal is defined as a variable in uncomplemented or complemented form. Then for an n variable switching function, f of x1, x2 up to xn, the product term, that is an AND operation for all the n literals, is called minterm. So this is a definition of minterm. Okay, product term that is an AND operation of all the n literals is called minterm. So suppose we have this switching function f of abc, that is function of a, b and c variable, is equal to a b bar c plus a b bar c bar plus a b c. So in this function, we have three different minterms, and those are nothing but a, b bar, c, a, b bar, c bar, and a, b, c. So these are nothing but three minterms. So minterms are nothing but product terms. Okay, this you have to keep in mind. And product term of what? Product term of literals in the function. Okay, next, max term. For n variable switching function f of x1 up to xn, sum term. Previously we had seen product term, now it is sum term. So sum term or operation of all n literals is called max term. So this you have to keep in mind. So let us assume this is a function. Okay, in this function, this a plus b bar plus c, this is nothing but your max term. A plus b bar plus c bar is again one of your max term, and a plus b plus c is also one of the max term. So these are max term. So the difference between min term and max term is, in min term you have product, in max term you have sum, or in min term you have AND operation, okay, and in max term you have OR operation. This you have to keep in mind. Now, canonical form of Boolean function. So canonical form or standard form is a unique representation of a function. Okay, we can derive two canonical representation directly from the truth table, and these are nothing but sum of product or product of sum. Sum of product is also known as disjunctive normal function, and product of sum is also known as conjunctive normal function. So these are the another name for these two terms. So sum of product and product of sum, these are the canonical form of a Boolean function. Now, canonical sum of product. So first of all, we'll see sum of product or SOP form. So what it is? From the truth table, identify all true minterm. Now, what do you mean by true minterm? You have to find out the product terms. Minterm is nothing but product terms. So you have to find out the product term which has output is equal to 1. Then this is called as true minterm. Okay, corresponding to row which has output equal to 1. Then this is called as true minterm. And false minterms are nothing but which has output is equals to 0. So whenever you want to define write a function for sum of product, you have to go for true minterms for output equal to 1. Then you have to take the sum of all the minterms like this. For example, for full adder, you can say a bar b bar c plus a bar b c bar plus a b bar c bar plus a b c. Similarly, c o means carry output is equals to a b c bar b c plus a b bar c plus a b c. And another form for writing down these two are nothing but this. Sum is equals to summation. Okay, why summation? Because we are adding product terms. So that's why summation of 1, 2, 4, 7. And here summation of 3, 5, 6, 7. Now how these terms come, that we will see in next. So this is nothing but your what we can say truth table of full adder. So in full adder, we can have two bits A and B, where we will add the carry input, previous carry, whatever is present. So we can have different 8 combinations because we have 3 different variables. So obviously 2 raised to power 3 is 8. That's why we can have 8 combinations. Now how to write down these 8 combinations? We can write down as usual, whatever we do every time. 0 1 0 1 0 1. So after every bit you have to change the bit. For B you have to write down 2 times 0 2 times 1 2 times 0 2 times 1. So this like this you have to write. And after this for A you have to write down 4 times 0 4 times 1 like this. So the output will be like this sum ends here. So 0 plus 0 plus 0 is 0 and there will be no carry. 0 plus 0 plus 1 is 1, there will be no carry. 0 plus 1 plus 0 is 1, there is no carry. 0 plus 1 plus 1 is 0 and there will be carry. Okay, Then 1 plus 0 plus 1, 0 is 1. There will be no carry. 1 plus 0 plus 1 is 0 and a carry will be there. 1 plus 1 plus 0 is 0, carry will be there. 1 plus 1 plus 1 is 1, carry will be there. So from this, we can write down this. Okay. So this is 0, 1, 2, 3, 4, 5, 6, 7. That's why we need to find out the 1 output. Okay, as we had said, true minterms we need to find. So true minterms are associated with this 1. Okay, so 1. So this is 0, 1. So that's why summation of 1, 2, summation of 2, 3, 4, summation of 4, and 7, summation of 7. Similarly, see out 0, 1, 2, 3. So 3, 4, 5, 5, 6, and 7. That's why I will write down C out is equals to sum of 3, 5, 6, 7. I hope this is clear to all of you. Is it clear? Now, how to write down this expression?
Yes, sir.
Now the question is how to write down this expression or how these expressions will come. What you have to consider, okay, if I want to write down for S, that is sum, I need to find out first 1 and accordingly I have to write down the bits. So here I have these 3 bits, A, B and C. So how I can write down? For 0, I need to write down A bar. Here also B bar. And since this is 1, we need to write down C. So what I can say? A bar dot, because we need to find out the product terms, B bar dot C, because this is 1, plus next minterm is true minterm is for this. So that is this, this and this. So this is A bar, this is B, this is C bar. So what I can write down? A bar, B, C bar. Similarly, I can write down for this. So A, B bar, C bar, because 0, 0 is there. So what I can write down? Plus A, B bar, C bar. Similarly, I can write down for this. So this is A, B, C plus A, B, C. So like this, we can write down for sum. Similarly, you can go for C out. So C is equals to, what we can say? We need to take this one. So this is A bar, B, C plus, we need to take this one. So A, B bar, C, we need to take this. A, B, C bar, we need to take this. So A, B, C. So like this, we can write down the expression for C. So this is sum of product. Next is product of sum, canonical form. So in this, we need to consider false max term. In sum of product, we consider true minterm. In product of sum, we need to consider false max term. False max term means we need to consider those terms which are having output is equals to 0. False, 0. True, 1, right? So we need to consider those rows which has output is equals to 0. So for each false max term, form a sum term where a variable will appear in uncomplemented complemented form if it has values 0 and 1 in the row. So uncomplemented for 0, complemented for 1. So that can be written like this. And another way of writing down representation is this. Okay. Since this is product of sum, that's why you can find pi symbol over here. This is nothing but product symbol. So again, we'll take the same truth table of full adder. So we need to find out the terms related to 0, that is false max term. So these are the false max term. So sum is equals to pi of 0, 1, 2, 3, 5, 6. So 0, 3, 5, 6. That's why sum is equals to pi of 0, 3, 5, 6. Similarly, we can find out for C out. So C out is equals to pi of 0, 1, 2, 4. 0, 1, 2. And if we want to write down the expression, how we can write down? Sum is equal to this. So in product of sum, if 0 is there, we need to consider it as uncomplemented. That's why I can write down A plus, again B plus C, and then we need to take the product of sum. So first of all, you have to take sum, and then you have to take product. Next is this. So A plus 1 is there, that's why B bar, inverse of previous one, B bar, and 1 is there, that's why C bar plus C bar. Similarly, you can write down remaining for this and this, that is A bar plus B plus C bar. For this, A bar plus B bar plus C. Like this, you can write down for sum. Similarly, you can go for the C. So like this, we can find out the canonical product of sum form for the given truth table. So that is the end of today's presentation. If you have any difficulty, you can ask. Do you have any difficulty? Please ask. Any difficulty? No difficulty? Okay, fine then. We'll stop over here. In next lecture, we'll go with the simplification forms. And thank you all. All of you can leave the session now.